It says the Square Pyramid of Memphis, Tennessee was originally built in 91 as a 20,000 seat sports arena. It reopened in 2015 as a mega store that includes restaurants, bowling alley, and shooting range. Find the exterior surface area of this building with a slant height of 490 feet and a perimeter of 2,364 feet. Okay, so they are asking for the exterior surface area. All right, the exterior surface area. And in this case, it's sitting on the ground, so they literally are asking for the lateral area here, And so what did we have to do to find the lateral area if it has a square base? I'm assuming it's a square base. Yeah, square pyramid. And they gave us a slant height. They gave us the perimeter and the slant height. What did you need to do? Multiply, and then because it's a pyramid, we need one more factor in there. 1/2, right? So you should have done... The lateral area of this should have been 1/2 times the perimeter, 2364, times the slant height, 490. You should have gotten, this should have been your answer, square feet. Square feet for lateral area. All right, that was number 20. The next three are all cones, circular cones, okay? So for 21, 22, and 23, they specifically tell you in the instructions you're talking about a cone, and they give you several different scenarios, and they want you to find something. This says find the slant height if the surface area if the radius is 4 centimeters, and the lateral surface area is 112 pi centimeters squared. So first of all, let's talk about lateral area of a cone. The lateral area of a cone is just like the lateral area of a pyramid. It is 1/2 perimeter times the slant height. But in this case, perimeter is the circumference because we're talking about a circle, okay? And so for this, it's going to be 1/2 2 pi r times your slant height. And these two guys cancel each other out. 1/2 and 2 is just 1. So it ends up being pi times r times L. All right, perimeter times slant height times 1/2. That's what happens with a circle, just because of the 2 pi r cancels. All right, they gave us the radius, right? And they actually gave us what the lateral area is. And they want us to find the L. All right, so we're going to fill in everything we know. We know lateral area is 112 pi. We know that the radius is 4. So we're going to plug in a 4. So we have 4 pi times L should equal 112 pi. Now the pi's are going to cancel out. If you divide both sides by pi, they will just cancel each other out. So to find L, what do we need to divide by? 4. All right. What happens when you divide by 4? You should get 28 centimeters is my slant height. 28 centimeters is my slant height. They also want surface area. Now, surface area is just going to be my lateral area plus one of my bases because it's a cone. If it were a cylinder, I would have 2 bases. It's a cone, so I have 1 base. All right? So I really just need the area of a circle. 1 circle is all I have to add to my lateral area. All right? And remember, for a circle, the formula for that base is going to be pi r squared. So we're just going to fill in lateral area. Well, that was 112 pi. 1 base, my r was 4, so that's going to be 4 squared times pi. So I have 112 pi plus 16 pi. So I'm going to get 128 pi. And this was in centimeters, so centimeters squared. If you plugged it in and got a decimal, you would have rounded that and gotten approximately 402.1 centimeters squared. So it just depends on if you plugged it into your calculator as to which answer you gave me there. All right. Surface area, that's just your lateral area, your faces plus your bases. In this case, we have 1 base, so we just had to add 1 of those. For 22, it says find the radius and surface area if the slant height is 6 meters and the lateral area is 18 pi meters squared. So once again, they gave us some information. Remember, lateral area ends up just being pi times r times L. All right. They gave us the lateral area. They said the lateral area is 18 pi. They told us that the slant height is 6. So we know that the slant height, if we fill that in, we get 6 times pi times r. All right. Well, divide both sides by that 6 pi. The pi's are going to cancel out. Pi's will cancel out. We get 18 divided by 6. R is going to equal what? What's 18 divided by 6? 3. So we have 3 meters for my radius. And then they wanted surface area. Again, they gave me lateral area. So surface area is just going to be my lateral area plus one of my bases. If I figured out my r, then I'm going to just plug it in. My lateral area was 18 pi. The formula for a circle is pi r squared. So I'm going to square that 3 and multiply by pi. So I get 18 pi plus 9 pi gives me 27 pi meters squared. And then again, if you plug it in, if it wants decimal form, you would get 84.8 square meters. If your instructions say exact, it means leave it with a pi. If it says round, it means plug it into your calculator with pi and round. All right, so exact means leave it with a pi. Round means plug it in. All right, last one, and then we're going to move on to volume. Find the slant height and lateral surface area if the radius is 10 and the surface area is 220 pi square inches. All right, so let's talk about surface area. Surface area is lateral area plus base. All right, so lateral area, that's going to be 2 pi r times my slant height times 1/2. That's my lateral area. My base is going to be pi r squared. And again, these cancel, so we have pi rl plus pi r squared. All right, pi rl plus pi r squared. And then they tell us what the surface area is, right? That's 220 pi. All right, so we have to use a little bit of extra skill here to do this particular one. All right, so in this case, you can divide everything by that pi just to get that out of the way. All right, so we have 220 equals r times l plus pi, not pi, we canceled out the pi, plus r squared. All right, and so we look and see what they gave us. They gave us radius, right? They gave us radius, so we can plug that in. They told us the radius was what on this one? The radius is what? It's 10, right? So we have 10 times L plus 10 squared. What's 10 squared? 100, right? So we can subtract the 100. All right, 220 minus 100 is 120 times 10L. What's my final step to find my slant height? Divide by 10. What is my slant height? You should have gotten 12 inches, right? And then you can just plug it in to find lateral area. You already know your surface area. All right? Questions on that? So far we've done 2 dimensions. It doesn't feel like it because we've been dealing with 3-dimensional figures. But what we've been solving for is actually only 2 dimensions. We've been solving for what happens if you were to lay it out and get all the surface areas, whether it be lateral area, just talking about the faces, or whether it be surface area where you actually add in the bases as well. All right, but we've been talking about 2 dimensions. All right, if I were to, we've really been saying, hey, what would you do? How much paint would you do to paint the whole pyramid, right? We have not actually talked about what would happen to fill them up. All right, and so now we're going to add 3rd dimension. That's what happens when you fill it up with something. And we're going to start with prisms and cylinders. So we're going to talk about like 2 bases, right? And if you were to fill it up to the top with something, whether it be the aquarium, we figured out what the glass was, but now how much water can you put in the aquarium? That's the difference between surface area and volume, okay? Surface area is just the outside areas. Volume is what happens if you were to fill the container up with something. All right, and so the definitions here seem like they would just be kind of common sense, but they want you to get a picture of what you're actually answering when you answer these questions. A cubic unit is a cube whose edges measure 1 unit. So they give you an example, looks like a Rubik's Cube. A cubic centimeter, a cubic foot, a cubic yard, a cubic meter, or any other unit, okay? So what you're basically saying is, if it is inches cubed, you're talking about 1 inch by 1 inch by 1 inch. How many of those can you fit inside this container? Okay? That's what you mean by cubic measure, a cubic unit. If it were feet, 1 foot by 1 foot by 1 foot high, how many of those cubic feet can you fit inside this room? That's what volume is, okay? A volume of a solid is the number of cubic units you can fill the entirely completely. So you're filling the interior completely with these cubic units. All right, it's really easy to picture when you have a cube. It's a little more difficult to picture that concept when you have something like a pyramid, because you can no longer think of these cubes filling it up. But that's what it actually means. How many of those would fit inside completely and fill all of the area on the inside with a cubic unit? All right? So let's look at some of these postulates, then we're going to do some of these. Volume postulate. Every solid has a volume given by a unique positive real number. All right? Again, this seems very common sense, but if I give all of you the same prism with the same measurements, you should get one answer for volume. All right? Not that we necessarily will, but the fact is there's only one answer. That volume cannot be different if it's the same exact prism. It only has one volume. Volume of a cube postulate, the volume of a cube. So a true cube, like the Rubik's Cube, has all measurements the same, which means if you know one of the measurements, you can figure out the volume. It's just that measurement to the third power. All right, that's a cube. Volume addition, if the interiors of two solids do not intersect, the volume of their union is the sum of the volumes. So if you have two figures put together, you can calculate their volumes individually and add them together. That's the volume of the whole thing. Congruent solids have the same volume. All right, let's look at this theorem, and this is how they actually come up with the formula for volume. A cross-section of a prism that is parallel to the base of the prism is congruent to the bases. Cross-sections are congruent to the bases. All right, so let's look at the actual theorems dealing with volume. Page 423 in your books. The volume of a rectangular prism is the product of its length, width, and height. All right, length, width times height. This is probably one of your pictures on your thing here, but I actually want you to remember the next one. The volume of any prism, whether it is rectangular or any other, is the area of the base times the height of the prism. Now, this is the formula you need to be concerned with, because this one right here is for any prism. Any prism. That capital B for this formula and the capital H are important, all right? Capital B means the area of the base. Capital H means the height of the prism. Why is this important? Well, because if you have a rectangle as your base, then your rectangle itself will have a base and height. Okay, so what I'm saying is if you have a rectangle as the base of your prism, that rectangle is also going to have its own base and its own height. That's how you calculate the area of a rectangle. All right, but if you have a rectangular prism, y'all get to see my amazing drawing skills here. If you have a rectangular prism, all right, then all of a sudden you have a base and height for the little rectangle down here. And then you have an actual base and height, meaning area of that rectangle and height of that prism, okay? And so what you want to make sure is that when you're given this information, you don't actually accidentally use the wrong height. Like sometimes they'll give you the height of the triangle. Well, that triangle is just your base. They're not talking about the height of the prism itself, okay? And so that's why they use those capital letters. They distinguish between area of the base, height of the prism. That's what these are talking about. Because if you were to take every single rectangle and stack it on top of each other, that would be the volume. That would be the volume, okay? So let's look at this first example. And it doesn't matter what your base is. This is why you have to go back and remember all of your formulas. Your formula for a triangle, formula for a trapezoid, formula for a regular polygon, which we're about to do. You have to remember all of those and your special right triangles and how to calculate those as well to make sure you can get that area of the base. All right. Example 1, find the volume of the regular prism. Find the volume of the regular prism. Well, in order to find this volume, we need the area of the base and we need the height of the prism. They gave us one of those. They gave us the height of the prism, right? So we know the height of the prism is 4 square root of 3 centimeters. We know that. Now we need to calculate the area of the base. The first thing you want to do to calculate the area of the base is figure out what type of base you have. We have a regular polygon, all right? We have a regular polygon, all right, right here. That is my base, all right? They gave me one side length of the base, 8 centimeters, and then they indicate that there is a measure right here, but we don't have that measure, okay? So then I have to go back and say, area of a regular polygon. What's the area of a regular polygon? That is 1/2 apothem times perimeter. So I have to know that formula to be able to do a volume formula. Everybody see that? And then on top of that, they didn't give me the apothem. So then I have to calculate the apothem, all right? I have to calculate the apothem. Now, this is a little bit easier because it is a hexagon, so it's 6-sided, all right? So basically with 6-sided, if I were to create this triangle right here, that's going to be 60 degrees, okay? 60 degrees. So if I were to pull that little triangle out here, 60 degrees means it's an equilateral triangle. So if this side is 8 centimeters, then that means this side is 8 centimeters and this side is 8 centimeters. That's what's nice about hexagon, all right? I desperately need the height of that triangle though, because that's my apothem, all right? And so if I want to calculate the height of that triangle, I can say, well, if it goes down here, that makes that 4. And so now all of a sudden I have a triangle that looks like this, 4, 8. What can I use to calculate that height, which is actually my apothem? Pythagorean Theorem, all right? So I would say 4 squared plus my apothem squared is going to equal 8 squared, right? Pythagorean Theorem works here. There may be times when you have to use special right triangles, which you can if you desperately love special right triangles. Yes, it's going to be 4 square root of 3. Yes. So if you like special right triangles, you have a 30, 60, 90 triangle with a short side, which means you can use that if you remember it. If you don't, you can use Pythagorean Theorem, all right? Pythagorean Theorem says that I am going to get a squared equals 64 minus 16. What do I get there? What's 64 minus 16? Right? Am I done? Is that my apothem? What do I have to do here? Square root, all right? Square root. So my apothem is going to be the square root of 48. Honestly, if they want it in decimal form, you can just leave it like that, right? You can just leave it like that because you're going to plug it into a calculator anyway. If they want exact, then you're going to want to factor that out, all right? You want to factor that out. So it just depends on what they want. In this case, if you factor it out, you do get 4 square root of 3. So that would be your apothem length, all right? So we have 1/2. My apothem we now know is 4 square root of 3 or square root of 48. It's the same thing. What about perimeter? What's my perimeter? Yeah, they gave me a side length. 8 times what? One side length is 8. How many sides do I have? 6. So my perimeter is that. This whole thing represents that B right there in that formula. Does everybody understand that? We found the area of the base. The reason I'm drilling that into you is because sometimes in these problems, it takes so much work to get the area of the base that you get it and you're going to circle it and you're going to move on. And you are not done with the problem. All you did was calculate the area of the base with that information. Now, I will say, unless you just want to do it step by step, you can put it all into your calculator. So you can take this whole group right here, and you could say, okay, the volume equals 1/2 square root of 48, or 4 square root of 3, however you left it. 1/2 times the square root of 48 times 8 times 6, which is 48, right? And then that times my height, 14 square root of 3. You can plug all of that into your calculator, all right, if you want it in decimal form. Or you can do it piece by piece. And you can say, okay, I want to figure out the area of my base. I want to figure out my height, and then I want to multiply those. If you do it step by step, you have to show me, or else you're going to get a rounding error from me. Okay, so you have to show me if you rounded within it, because my answers are always going to be rounded at the end. Does that make sense? So if you do it piece by piece and you calculate this and then plug in a rounded base, show me what you plugged in. If you do, they actually rounded this to the whole number. All right, so they actually rounded this guy to 4,032. Now notice my units all of a sudden are no longer squared. I have 3 units that I've multiplied by. I've multiplied 2 units in the base and a 3rd unit for the height. So now my units are cubed. So when you give me your units here, you're going to do cubic units here. So this first one is the triangular base. The second one is a regular polygon. I will say they were much nicer on this regular polygon. They gave you the apothem. They gave you a side length. So it's not even making you calculate that apothem for this one. Area of the base times the height. You have 2 different types of figures for bases. You have a triangle, so you need to recall your area of a triangle. You have a regular polygon, area of a regular polygon. Couple things they want to point out. There's a difference between a right cylinder and an oblique cylinder. I will tell you all the prisms and cylinders I give you are going to be right. All right, so when they give you the height, it's going to be the height. But they do want to point out, just like when you have a triangle like we just had, it has to be perpendicular distance from the top down. Every cross section of a cylinder that is parallel to the base is congruent to it. So if it's parallel to the base, then it's congruent, and the same thing happens. The base times height is going to be your formula here. Now, the difference between a cylinder and anything else is that you always know what that's going to be. If it's a cylinder, it's a circle. So the area of the base is always going to be pi r squared for a cylinder. You don't have to worry about that. If it's a circular cylinder, and I don't give you any ovals, so if it's a circular cylinder, pi r squared times your height. Pi r squared times your height. That is the same exact formula that we just used for a prism, base times height. All right, base times height. So let's look at this. How many cubic inches of sand are needed to fill this cylinder? How many cubic inches of sand are needed to fill this cylinder? Well, the volume is what they're asking for if they want to fill it up with sand. we're going to do the area of our base times our height. The area of the base is pi r squared times our height. They gave us r, pi times 5 squared. They gave us our height, 12. All right, we get 300 pi, or if we plug that in, we get 942.5 cubic inches of sand are needed. 942.5 cubic inches of sand. Cylinders are very simple. They're easy to do. All right. This says, to what height would 22,000 cubic feet of corn fill a silo with a diameter of 20 feet? All right. So first of all, if they give you a measurement and it is a cubic measurement, they have given you volume. All right. So just by knowing that this right here, this unit is cubed, then you automatically know that this is volume. Okay? So that tells you they gave you volume. So they gave you volume and they're saying what height? What height? So basically they're wanting this variable right there. What is the height? Also pay attention to what they gave you. They gave you diameter. You need radius. Okay, so if they hand you diameter in this formula, you're going to need radius. So if my diameter is 20, what is my radius? Yes, it's 10. All right, so they said the volume then is 22,000 feet cubed. We're going to say pi r squared, that's 10, times h. All right, 10 squared is going to be 100. So I have 100 pi times my h. How do I solve for h? Divide by what? Divide by 100 pi? Yes. All right, and you can plug that into your calculator. If you do this in your calculator with the pi already in there, just a quick note here. In your calculator, you need to do this right here. All right, 100 times pi. You want to do parentheses. If not, it's going to divide by the 100. Then it's going to take that answer and multiply by pi. That's a different answer than if you do it this way. All right, you have to do it that way. You get approximately 70. It does round. So 70 feet. You'll notice my unit here is not squared and it is not cubed. What are they asking for? What did they ask for? They asked for height. Height is one-dimensional. All right? So they already gave me my volume, which was cubed. My units here are one dimension because that's all they're asking for is one dimension. Had I solved for volumes, that would be feet cubed. But we didn't solve for volume, we solved for height, right? And so you'll notice that I just have feet here and not feet cubed.